So I said the commonest example of an AC current can be represented using this equation. So when you are asked to generate an equation that can show that this current is an alternating current, this is an equation that should, because current normally has this equation, quantity of charge over what? Time. That is the equation representing current. So when you see this equation, this is an example of an ordinary current. It can be current under DC. But an equation that represents a current of alternating is I equals to I naught sine 2 pi f t. We all know what pi is. We all know what f is, that's frequency. And we all know what t is, that is time. The only thing we should be looking at the meaning now is I naught. And I naught is called peak value of an AC current. Peak, maximum value of an AC. So before we can get an alternating current, we need to know the peak value of that AC. We need to find value for frequency. We need to know what time. By the time you multiply everything here, so the type of current you'll be having is not any other current but an example of what? AC current. If I have this one to be the commonest type of AC current, therefore the commonest type of AC voltage too should be V is equals to V naught sine 2 pi ft. So the analysis I have given for this go for this. So when you are asked to give an example of an AC current or an equation that is used in solving an AC current, that is the equation. An equation that is used in solving voltage under AC. This is what? This is an equation. So I am done with definition of this and the representation of this in an equation. Now, what value is called peak? Because here I call this one peak. How do we define it? This peak, this I naught, which is peak value of what? AC. Very simple. When you hear peak, peak means maximum, the highest point, the top. So I can say the maximum, so peak value of an AC is the maximum value or the maximum numerical value of what? AC. The maximum numerical is coming from the word number, meaning the greatest number that can be attained by an AC, the greatest number that can be obtained by an alternating current is called what? Peak. So if an alternating current obtains 50, meaning the peak value should be 50 ampere. So peak value is the maximum or the highest numerical value of an alternating current. And the symbol is what? I naught. I can see the formula for I naught anywhere. When you are asked to calculate for I naught, I can use this by making this the what? The subject. I can derive an equation for it here. I can derive an equation through Rn squared, because Rn squared itself is I Rmc squared is equals to I naught over root 2. I am still coming back to that. So what is Rms? That is root main squared. That is another thing that must be discussed under alternating current. After taking the definition for peak to be the highest numerical value, when we say AC is having an RMS, root mean square. So root mean square, if this one is the maximum current, then this one is a constant or steady current. Constant or steady current that will generate the same amount of heat at the same time interval and the same what? Resistance. Let me take that definition again. R mean square of an AC is a constant current. That one is not the greatest. Why this one is the greatest? This one is a constant, meaning something that will not change. Tomorrow it has the same amount. Next tomorrow it continues with the same amount. So R mean square of an AC is a steady or a constant current, but that will generate the same amount of heat or energy at the same time and the same what? Resistance. We know that there are some factors that affect current, but in this type of situation, at the same time, at the same resistance, the current is always steady. And if that current is steady, the current shall be called root mean square. A steady current that generates the same amount of heat when the time is constant, when the resistance is constant, those two factors must be there in the definition. The time must be constant. The resistance must be constant. So that's the reason why the current too must be what? Constant. So a constant or steady current that can be generated when the time for the current is constant, the resistance in the current is, sorry, producing the current is also constant, is called R main square. Now, relationship between peak and RMS. This formula shows their relationship. And if you want to know RMS current, which is this, you have to know peak current, which is this, divided by what? Root 2. So when you are asked to show relationship between RMS and peak current, so this equation shows their relationship. At the same time, I can generate another relationship. So this RMS can as well be V, let me say VRMS over either Z, over either Z. What am I trying to derive? I am trying to derive according to Ohm's law that we can have V is equals to what? IR. By the time you make this one the subject, it become I is equals to V over what? R. That's exactly what I'm doing. So I, which is IRMS, can be obtained using VRMS divided by resistor. But because I'm not using only resistor here, I have told you that it is a situation where the three of them behave like regulators. So when the three of them behave like regulators, we don't use R, then we use what? Z. It shows that all of the resistor, capacitor, and inductor are now our what? Regulators. And that's why I'm changing the value from an ordinary, this is an ordinary current, but now we are talking about AC current. So in a situation where the three, so we can get this using either using this. So when the guy says show relationship between RMS and I naught, this is their relationship. When the guy says show relationship between RMS and VRMS, this is their what? Relationship. We continue from the next class.